Welcome, everyone. Hope you're having a great week and you're excited about KubeCon. I'm really excited about this network security AMA here with Brad. Hey, Brad, how are you doing?
Good. How are you doing?
Doing great.
Excited to be here.
Yep, exactly. And just to do a quick round of introductions, I'll go first, and then Brad, you can introduce yourself. My name is Pawan Shankar. I run product marketing for security here at Sysdig. Really excited to be here at KubeCon and answer all of your questions around network security.
Yeah, and I'm Brad Geesaman, co-founder of Darkbit, and we focus on cloud native and Kubernetes security posture assessments. Come from a pen testing background, but have moved in Kubernetes in the last few years, and you may have seen me around. So happy to be here. Thanks for having me.
Awesome. Likewise, Brad. It's great to have you here. So just to kind of, kick it off, Brad, why don't you tell us a little bit about what are some of the challenges that you hear from working with your clients as it pertains to, getting started with network segmentation, everything around network security in Kubernetes?
Yeah, no, definitely. That's a great topic. So network security in Kubernetes is, quite different from standard VMs and bare metal. And really that starts sort of from the defaults. What assumptions are we starting from? The defaults are quite frankly open. The whole design goal was that a pod on one node could talk directly to a pod on another node. And there wasn't anything out of the gate that was going to say, no, you can't do that. And that was to help with developer velocity and getting applications to work in various situations. And so even early on in Kubernetes' existence, the CNIs, the container network interface APIs, that wasn't even a thing. It was just an add-on you added on, didn't have this really in-depth understanding of how to even block from pod to pod or make that a reality. So somewhere in the 1.3, 1.4 era, when that started to take shape, you had the network policy resource that made it possible to say this pod can talk to this pod on just these ports and protocols and things, and then across namespaces. So sort of starting out from the defaults, it sort of emanated, and we still see echoes of that today where, when I'm doing assessments, I'm looking at clusters from a multitude of angles, typically outside in. So API server, its components, the configuration, is it exposed? What workloads are exposed? What's behind load balancers and things. But then there's this center, the workloads inside the cluster. If they get compromised, what's the risk? Like what happens? And when I say compromise, I mean, there's a vulnerability in the web framework and there's a shell there that an attacker can control, or somebody pulls down an image that is backdoored or has a vulnerable dependency, something where the attacker is basically sitting on that pod and they're looking at the world from the perspective of that pod. And in the defaults, that's everything. That's egress is typically to the internet is typically available. So that's great for sending data out, getting reverse shells, establishing command and control. But when you're sitting on that pod, that workload, you don't necessarily have to be root or privileged. You're just on that pod. Well, you can see all the other workloads, all the other pods and the listening services in that cluster, and all maybe the instance credentials attached to the cloud instances if they're running in the cloud. And that just opens the door wide for lateral movement. So one of the key recommendations that we sort of prioritize for customers is when you're doing all the basics, the outside, the configuration of the cluster, like what's next? It's sort of a combination between solid RBAC, so access to the API server, secrets, tokens, permissions there, but then lateral movement, network, layer 4. And that's where one of the strongest ways to implement network policy, to prevent that lateral movement, that's how you do it. That's from each workload's perspective, you say, what things need to talk to it and what things does it need to talk to? You write policies around that. However, what I tend to see is that's not the default, that's not adopted early. And so that recommendation comes with it. The longer you go, the higher the effort, the higher the lift to put that in place later. And there's a couple challenges that come to that. Why is that the case? Well, even if you own some of the deployments, like your front end, your back end, your message bus, those types of workloads, you might not be the only person running workloads in your cluster. The cloud provider might have their add-ons. You might have security add-ons, third-party add-ons. operators. You don't own that code, and that code is running in that life cycle, and you're running your own code in your own life cycle, but you have to write network policy as a consistent strategy to say that every workload gets a network policy and what should it be talking to. You might not have that context. So a developer says, yes, I know my web service is listening on port 8080, and that's all I know. And you say, well, wait, doesn't it make a connection out to a cloud API for a storage bucket? And they're like, oh yeah, forgot that. That would have been a misapplied network policy that would have broken production or something if you just put on a network policy without really understanding, right, what's happening with that workload. So you have the developers that really don't know the entire bit of their context. They know a little bit. You have the cluster admins who might know a little bit, but even then, not everything. And then you have the security team that's just like, I just want least privilege. How do we least privilege this thing? And so that's really hard when not one person knows the entire context. So I've seen it done, and I've seen people do it manually. The trick is if you do that, you're good. You set your baseline. 5 minutes later, another deployment comes along, or another namespace gets added, or another deployment changes its ports, or somebody pushes a code change that now talks to that cloud API. You have to kind of assess what changed, because it might be multiple places where those policies get changed. So I think that's some of the things that we see when it comes to network security inside Kubernetes. It's not on by default. It's extremely challenging to add on later after the fact. And it's really tricky to keep up with. However, the benefits in terms of limiting blast radius of a compromised container are incredible. It's a huge, huge step in terms of defense in depth.
Yeah, no, that makes a ton of sense. And, that resonates a lot, because when I talk to customers, I hear a lot of the same problems, right? And to your point earlier around preventing lateral movement, that's the number one problem that they're trying to solve for. And when we talk to customers, the basics is they just don't have visibility into what apps and services are communicating with one another inside Kubernetes, right? So Kubernetes makes it sort of hard for these different teams to have that shared context, right? So to your point there, and I think when we talk around the workflow with developers, a lot of times sometimes they have the application knowledge, like allow on 8080, sure. But they are not the ones that have the domain knowledge of Kubernetes to be able to apply the network policy. Like if you throw a YAML at them, they're like, I don't know what to do with this, right? And on the flip side, you have the ops team that they live in Kubernetes, they speak the language, but they're like, I don't know what the app does, so how do I create this policy? So a lot of times it takes weeks, if not longer than that, for these teams to align, have a shared understanding of what the application should behave, how should the application behave, what that communication should look like, because
right,
the network policy exists, but it's up to you to know your app, right? And you need to define the network policy, and that requires developer, the ops, and the security to all be on the same page, right? To create that least privilege, like you said, making a policy that's not too permissive, but also doesn't break the application functionality, right? So making sure you're able to do that in a cohesive way that's streamlined as part of your deployment, all of that is, I believe, table stakes when addressing network security for Kubernetes. And, so some of the things, unless Brad, you had something to add there.
No, that's couldn't agree more. Yep.
And some of the things that what we're trying to address, we just did our latest launch around network security for Kubernetes. So really simplifying the ways for DevOps and developers to have visibility and apply that microsegmentation. So one key thing is we provide that visibility from the get-go. So a lot of times today, teams tell us, well, when I think about network visibility, it's just a bunch of containers talking to a bunch of other containers, and I don't really know what application is communicating, what service are talking to each one another. So what we're doing there is just automatically, collecting that network connections from the syscall events, and then enriching that data with the metadata from Kubernetes. So being able to now organize all your network communication by, a Kubernetes lens. So to say, it's not just a group of containers that you've tagged that is talking to other group of containers, but now you can see a deployment talking to a service, to a stateful set, and seeing it from that lens of Kubernetes allows your teams to understand, okay, how are these different applications behaving, right? So before you even segment, having the visibility first into, okay, what is actually happening inside Kubernetes right now, right, with full context. So that's the first problem to solve. The second one is really to use the native controls of Kubernetes itself to apply that network segmentation, right? So Kubernetes by itself has a lot of powerful controls, and just getting to use those is a good practice because it's just, part of the platform, so you don't have to reinvent the wheel. It's an open standards approach, right? And also it just has better performance and scalability as you start to scale your clusters, just using the native tools. So one of the second thing that we're doing there is just making it easier for DevOps to use and modify and apply network policies, right? These layer 4 controls, as you mentioned. So one of the things, what we're doing there is first just using that visibility as a baseline to say, okay, here's what your network traffic looks like today. And here's a baseline policy that we've built for you. So you don't have to start that work from scratch, right? So just make it easier for you to have some amount of work done for you automatically based on the observed traffic. Then we provide, a way for you to make those modifications with a simple UI. So rather than throwing a YAML at the user, we just allow them to use this interface to make those policy changes, apply and whitelist what should be allowed and what should not be, using that application context. And then that generates a network policy. And then via a CNI like Calico, you can just apply that natively, right? So a good question that often comes up here is, network security, when we talk to a lot of DevOps teams, they're not really thinking about that early on. A lot of times they're thinking about image scanning, and it's now starting to think about runtime detection with Falco, but network security is sort of pushed, later in the cycle. And what I often tell customers is, as they mature with Kubernetes in production, a lot of those use cases that you were used to in the old days of network security, IDS, right, IPS, all of those are starting to become more relevant. So these advanced use cases around runtime security, network security, incident response, all need to be part of your container and Kubernetes security plan and framework early on. So you just know how to prepare for them when you do scale up, you have a proper implementation in place.
Yeah, like when is too early and when is just the right time and when is too late to implement network policy. If you're starting out, and you're doing it in a dev cluster, you have nothing in production, you're figuring things out, you're figuring out how your app works. But I like to recommend in the QA or stage or test, whatever your nomenclature is for the pre-prod, this is going to be the deployment I'm literally going to take, the manifest I'm going to take and put in production, that's the gating point. So when you're wherever you are in your journey of getting something shipped to prod, if you already have something in prod, go back to your test environment and really understand, what network policies you want to put in and put it there.
Yeah.
And get really confident with that and use, tools and visibility and things to understand what your apps are really doing and then ship that into production. I'm not as opinionated on dev because dev, like you're coding and you don't know if you need an API call or talk to this workload. Maybe you're going to, or maybe you're going to write another microservice that broker something over to that. You don't have that pathway necessarily laid out. But once you sort of solidify that and you're starting to make a release candidate or a release, and you're putting that through its paces in the test environment, that's where you really want to bake it in and get really confident. Like, look, all my smoke tests pass, all my integration tests pass, all this good stuff. I can exercise all the functionality in my workloads. That's good practice anyway, but now you know what network traffic is coming in and what's going out of all the workloads. And there's no surprises. There's no like, why is it pulling from that repo over there? I had no idea that it's bringing in this thing or it's talking to this other system that we weren't aware of. You want to know that in tests and not in production.
Yeah. No, that makes a ton of sense. The other question that that's coming up is, how does this relate to, how does this tie into existing security principles? And I think a good approach that this connects to is zero trust. So a lot of security teams, and security operators and practitioners understand the concept of zero trust, and it's a broad term, right? We don't have to cover all of zero trust here, but the practicality of how to apply zero trust in Kubernetes, when it comes to network security, makes a whole lot of sense, where, you know, the concept still remains, where your traditional network security mechanisms of opening and closing ports based on IPs doesn't make a lot of sense in Kubernetes, right? These static IPs don't mean anything. And like you said, if someone gets root access, right, a lot of times the first way they will try to do an exploit is to see what are some open network policies and do some sort of port scan and see how can they move around, right? So this approach of zero trust, where you don't trust anybody inside the network or anybody outside the network, and really, you know, define explicit trust based on the application, based on the context, is a really great way to think about zero trust in Kubernetes. And, you know, as you're moving workloads to cloud in Kubernetes, it's a good time to sort of use that as a catalyst for applying the right framework in this greenfield, you know, opportunity that you have, and just start correctly with native controls and applying the zero trust mechanism. So that's what I always tell, you know, clients when they're moving over to Kubernetes is think about those existing security frameworks and see how you can apply them when it comes to, you know, network security.
Yeah, the zero trust aspect in Kubernetes, like getting down to the pod is about as far as you can go. But like by default, the trust boundary is literally every workload inside the cluster. So we need something, you know, much smaller than that to be able to say, you know, this workload on this pod on this node and what it can talk to. That's sort of the you know, the label selector, namespace selector. That's where that really targets and makes that a possibility. Yep. It's just you need to know the behavior of your application to be able to make those you know, decisions correctly. But when you do, it really does. It's sort of like the underappreciated third pillar of blast radius protection. Yep. That you know, for a workload that gets compromised. Because if you're sitting there with a shell and you're trying to curl the API server or download Kubernetes control or something, you might not be able to download the binary. You might not be able to you might not have curl locally, so you're going to try and get something. You might not have access to that if you're doing network policy, right? You're trying to hit cloud credentials, you just might not be able to hit that magic IP. You're trying to hit Tiller or something that just might not be there. You're stopped in your tracks. Now, if you didn't have network policy, maybe all that was possible. And so you did everything else right, but you didn't, you know, work on that layer 4 blast radius, and still bad things can happen. So it really needs to support the rest of that story.
Yep. And this is a great kind of segue to the other common question that I always get asked, which is, okay, I have some sort of virtual firewall, you know, from a vendor or the cloud provider firewalls. Like, why can't I just use that? And the response is exactly what you said, which is, you know, you need that fine-grained context all the way down to the app level, and using those pod selectors, label selectors to define what that policy. These virtual firewalls don't have that visibility into you know, the Kubernetes environments. They don't really speak that language, so they will struggle in defining some of these fine-grained policies. So it just makes it harder for you to have, you know, that confidence in, am I blocking the, you know, that lateral movement, or am I preventing that from happening? And the good news is, if you use network policies, by default, they are part of the platform, right? You can use the context from Kubernetes to apply that into the network policies that are the default controls, and just make sure that that segmentation is defined correctly and accurately, right? And your security teams can sleep with confidence. You know, your DevOps and developers can continue deploying fast, and you know, that's kind of the North Star there.
Yeah, one thing I'll add, like, if you understand the behavior of your workload, not only do you have a better understanding of what is good, you will then have a much clearer picture of what therefore is bad if it occurs. But then, you know, so from the incident response perspective, like, wait, why is it talking to this IP? That's something we haven't seen before. We're getting blocked, logs blocking on the firewall policies. That's like your first indication of, you know, things that are being attempted. But there's like this second aspect of it, which is like, if you ever want to sort of like mature up, and I kind of see it as like mature up in a service mesh, if that becomes a thing for you, you can't succeed unless you understand what's talking to what in that context. So it's sort of table stakes just to be able to level up and do that effectively. You can't just go drop a service mesh on and say, yes, I have layer 7 and layer 4 working together, unless you know what layer 4 was for those applications to talk to each other. And then you get up to the layer 7, what's getting, what's setting. you have to build upon that. So if you're ever thinking of like, oh, I want to mature up, you can't skip over this step for all sorts of reasons. But that's, you just, you're going to be shortchanging yourself if you don't invest that understanding is really what I'm thinking.
Yeah, that's a great way to put it. It's sort of like table stakes, where it's part of that journey, right? You need to start with network policies and these layer 4 controls and segmentation, and then level up to service mesh. A lot of times people just say, okay, why can't I just use service mesh? And when you dig deeper and you ask, is that a requirement? Are you actually applying that today? Then a lot of times they're saying, oh, well, we're considering it. And the reality is that it's still further out from many people. So getting started with network policies, getting that down correctly and making sure that that works, and you have a strong understanding of how those network policies are working and behaving, allows you to be more confident in saying, okay, now, I'm ready for incorporating the layer 7 aspects on top, right? It's just like another OSI stack, right? You have to build on top of the lower layers. Just like that, when you're applying it here, build on top of network policies and then add service mesh on top.
Yeah, I was gonna sort of talk about the other pillars in relation to network policy quickly, because that's something that, what are the 3 things you have to do really well? You have to know where your containers are coming from, where those images are coming from, what's going on inside them in terms of dependencies, vulnerabilities, and reconciliation of that. That's like what code is running inside your pods. And then there's what things can the pod do. And so the 2 is typically what things can it connect to, and then typically what permissions does it have inside the cluster via the API server. So we're talking about role-based access control. Most people tend to do RBAC pretty well. They know like their front-facing pods. There's no need for them to be communicating with the API server. They just don't mount the service account token. That's a quick win. But you still have the network access. So when you bolster those 3 things together, you start to paint the picture, the boundary imbalance of limiting that blast radius, because you can't just do 1, you can't just do 2, you have to do all 3, and in some cases a little bit more. But those have to work in concert. So you might be thinking like, my RBAC's good. I'm using emission control and I'm limiting where my images are coming from, but there's all sorts of ways of compromise of that image or dependencies or misbehaving internal insiders that you just are not visible. You don't have that visibility. You don't have that protection, that defense in depth with, unless you bolster on that network layer.
Yep. No, that makes a ton of sense. When we think about that, absolutely, image scanning is table stakes as a first step towards making sure you're secure, and the shift left concept of embedding that into the scanning into your pipeline, scanning in your registries. If you're using admission control, that's great, right? Because what if a developer bypasses the pipeline and tries to deploy directly? You have something as an admission controller that can gatekeep that, act as a gatekeeper and basically disallow that image if it doesn't meet the specific criteria, right? So that is another additional layer. So definitely, all these fantastic controls exist. And then as you think about the next step is, okay, what do I do for runtime, right? You have tools like Falco that help you detect anomalous activity at runtime. And then network policies in Kubernetes, great way for you to apply segmentation. The other, a lot of times when we talk about network security to teams, they're looking at other container firewalls that are out in the market, rather than relying on these native controls. And often, what we explain to them is these are external tools that are, again, tampering with the infrastructure. They are also proprietary, so they don't really follow that open standard. So you, as a Kubernetes operator, want to have that transparency in how your policies are being implemented, right? What these tools are actually doing. So the native controls allow you to have that visibility because they're built on these open source constructs, and also allows you to scale, faster as you start to go into production, with more, confidence that nothing's going to break. Because if this tool were to go down, it could bring down a cluster, but our policies are native controls, right? So that's a better way to apply enforcement and microsegmentation when it comes to the network layer. I think the challenges is also around thinking about investigation. So one of the things you mentioned there for incident response, what we also hear from customers is, I have a network policy in place. Let's say I have something, defined. How do I know what are some connections that are being made that are failing, right? That could be some sort of indicator of potential attacks that might be happening. And just looking at that network layer and those connections and seeing, was there a successful connection that was made outbound? Was it unsuccessful, right? Some sort of denial of service or raw packet manipulation that might be happening. So having a log of all of those connection events is a great way to be on top of that, right? Just having the network policy, but also knowing the other side of the coin, which is what was failed, what was trying to connect. Right. So, we actually pipe all of those connection events that are generated inside your pod to Splunk. So if you're using a SIM tool like Splunk, you have an app there to see all these connection events, see your top talkers, right? Understand what connections were failed or were successful at the host level at that specific pod. All that detail just for your investigation purposes to be fully confident that you're not missing anything under the radar, right? Some sort of malicious network attempt under the radar could be something that you want to be able to investigate. So that's another thing that we help customers with.
Yeah, it's a good thing you brought that up. Like in terms of it, like what's happening that's bad. There's the things that are happening inside the pod. We'll focus on that, right? So Falco will be saying like, you wrote a binary below this path. Okay, maybe that's good, maybe that's bad. I don't know yet. Then there's connection attempt made from said binary. Ooh, that's starting to get interesting. The first question you might go is, did that succeed? Did that get there? And so the firewall logs in concert, putting those two together, will tell you what was tried, and it'll also give you success or failure. So if an attacker is trying things, they're constantly getting blocked, it's not saying that you're that's it. Like you don't have to do anything. It's just, that didn't succeed. So you don't have to further investigate, what that connection attempt was. You can look at what the IP was and make assertions of, they're probably trying to do this or probably trying to do this, but it was blocked. They tried to do this, it was blocked. That's a better story than, well, they tried to do 10 things and I can only sort of tell because maybe one of them brought a binary back down or added another payload or something that I think that's what was successful. Now I got to go look over in other log areas to find, the fuller picture. But if you had layer 4 and basically that pod didn't need to talk outbound to anything, you would know right away with a denial egress that any connection attempt is suspect because the policy said that this pod shouldn't be doing anything. So you have a stronger indicator or an intent that the security team can look at and say, that wasn't supposed to talk to anything. And here it is banging away, trying to phone home and do all these other things. In addition to, well, there was a binary that was run, home directory was changed, et cetera. So it paints a clearer picture of what's going on. You don't have to just go, well, I don't know what it did on the network, but I know it. Now you can have that visibility.
Makes sense. We have a minute left. Brad, is any last thoughts or advice for the audience that's listening? Any takeaways that you want them to leave here with?
There's so many things, but if I had my pick, I would say keep your eye on the admission control space, specifically with pod security policy. If you're relying on that or thinking of Open Gatekeeper or things like that, really, really keep an eye open. If you're thinking of developing on pod security policy, get involved with SIG security if you want to drive pod security policy's future, whether it should be there or should not. I see that's sort of like the big sea change that is just starting to come up of like, all the things that we know about, like what's really changing. That's actually a core thing that we're, sort of a lot of assumptions are built on. So if you have strong opinions, jump into SIG security and let folks know about that.
Awesome. And then from my end, again, just to wrap this up, right? We really discussed a lot about network security in Kubernetes and why the challenges of first visibility and then applying segmentation using the native controls are the key areas to address. And with our latest launch of Zero Trust Network Security that we just announced today, we provide that visibility, allow you to enforce segmentation using the application context, and then also allow you to investigate these connections, whether they're successful or failed. You can come check us out at sysdig.com. Read about how we are applying these network policies in more detail. We have blogs and videos, a ton of good stuff and content to educate yourself on. So enjoy KubeCon and definitely have a lot of fun in this process of maturing in Kubernetes.
Have a great KubeCon, everyone. Thanks.